All right, so hello everyone. So welcome to my talk, and my name is Boki Chen or Percy Chen. So I'm a PhD student at McGill University, and I'm also an active maintainer of the Sherpa open source project that we have mentioned multiple times during the past few workshops. So today I basically bring kind of latest update for the open source project and some new idea that we are experimenting with recently. So I said that this is more like experimental idea. So if you have any other ideas that you use in practice, or if you feel some different kind of thinking, feel free to leave them in comment and we can discuss it afterwards. Um, so basically the idea is that I'll go to this into this later, but the idea is that we want to kind of distinguish the core logic of LLM agents execution as well as, so for example, domain-specific code. And the solution we come up with it is basically use configuration as the agent definition. So for those of you who are probably not here in the previous workshops, so Sherpa is this open source project that started with the idea that we want to have a human in the loop multi-agent workflow thing. So basically, we have seen a lot of agent-based systems, and most of the time they're purely autonomous, that you input something and all else will be done by the larger model. What we want to do in this Sherpa open source project is that we want to have a human to get involved in this process. So basically, the agent may tell you, okay, I have some difficulty, I can not do this job, please help me. And with the human feedback, the agent will be able to continue to push the task on their own and create the ultimate result. So in this sense, we have treated human as some sort of oracle that the agent can ask if they have any problem with the task. At the same time, we have multiple agents working at the same time in the shared workspace with each other. So you can already say we have a problem here, right? The problem is that we have a lot of agents, and there can be like so many different agents depending on what use cases you have. It will be impossible for us to provide all the agents because you have your own use cases and others may have their use cases as well. So we have to find some way for people basically to support adding their own agents to work with the framework in Sherpa. So before we start with, just want to thank everyone as the contributor of this repository, and also potentially if you're also interested in contributing this open source project, yeah, just say yes, I want to contribute, and we can have orientation with you, and we'll introduce you to this project. All right, so let's back to the main topic. So we have the problem that we have a lot of different agents, and we want to add support user basically add their agents. So to start with, we first need to think about how the what is the agent. So I guess we have different definitions of agent depend on like each use cases. But what is the definition of agent in Sherpa? So basically in Sherpa we use, so the entire agent workflow is based on what they call the React loop, which is based on this paper. If you are interested in, it's a very nice paper. You can read it. It's very interesting. So we use React loop as the basic strategy for task execution. The basic idea is on the right. So this is the execution of a single agent. So basically, there are several components. So the agent would observe from the shared memory, like what other agents have done so far for the task, or what are the information provided by the human. Based on the observation, to update its own beliefs. So basically, kind of like put it simply, it will revise its prompt to adapt to this particular task. So what's core in this React loop is that we have multiple actions that the agent can select from this list of actions. So once the action is selected, we execute this. The agent executes this action. Depends on the use case, they may need to reflect or say verify if the output of an action makes sense. For example, if you want an action to provide you with a JSON format, does the JSON so first is the output a JSON format, and does it contain all the information you want? So that's the reflection part we have. So at the end, we need to make a decision to whether, for example, in this reflection, does it satisfy all the conditions? Maybe we all know that large model has its limits. Maybe after several attempts, we still can't resolve. So we still, for example, make the output as a JSON format, or still missing some information from the JSON output. Then in this case, we need to basically ask a clarification question. For example, we ask the user to help with us. If that's not the case, okay, then we have basically something that's generated, and we can save it to the shared memory for other agents to use, or basically give it to the user as the result. So you can already say that an agent, basically, this workflow works for all agents, but there are several variations that we can maybe change depending on different agents. For example, the list of actions will be different for each agent. For example, if an agent for a researcher, maybe they can search on the internet and write down ideas and so on. But you have an agent which is a programmer, then basically that you have something like writing code or read requirements and so on. The action execution basically depends on obviously the action you set, as well as some reflections. For example, when I write code, maybe I want to do verification to make sure that my code compiles. When I write when I write like just some text, maybe I just want to check the text, make sure that maybe I want to include some citations in the text, and those are the variation in the reflection. Of course, there are also other standard things that I want to change. For example, like prompts, right? For different action, we want to write different prompts so that large model can generate or select the action, execute the action based on the prompt. So previously, what I have done, so based on this particular workflow, previously what I have done is that we would support users to support basically users to add new agents based on the extension of a base class, right? So for example, in this case, we have those things which are basically different for each agent. For example, the list of actions for the agent, the action selection, how the agent should select the action, as well as the reflections, for example, the verification we do for the agent. So that's the things and also the prompts, or at least the prompts. I just write one prompt here for simplicity. So we have those things that varies for each agent. So we have some default agent, for example, the QA agent, the NLP agent, or say software modeler that can create softwares. For each of the agents, we maybe give them some default prompts as the default option, and the user can either create a new agent by create a new agent class, or create a new customized instance of agent classes. So this is the way we did. But the problem with this is that it's not very trivial to add a new agent, right? So first you have to write some code, and people maybe don't like to write code most of the time. The second is that the new code or the new class that we introduce for each different agent doesn't really provide many value, right? The only thing we add is the only value we add is some static options like strings, list of actions, and so on. And those things are very declarative. So based on this, we are thinking like, can we do this in a codeless way, right? Can we configure an agent without writing any code, but maybe just writing a text file to configure a new agent? So this is basically what we come up with at the end. So we basically get the action selection strategy, and we change from the term reflection to verification, just to make it a bit more confusing. So just make it a bit more formal, so that we actually verifies the things not only to reflect on the current performance. So what we do is we grab them out into different into its own classes, and basically abstract them out from the agent class. Now what happens is that we basically can utilize a very fancy library called Hydra. If you're not familiar with Hydra, I highly recommend you to do that, to check it out. It's really interesting. So that after that, what we do is we can configure. So everything will become an instance of agent class. So and to configure one instance, we can basically utilize Hydra's ability to configure object in Python. So we only allow, so now we disregard whatever has with the idea of intention of creating new classes. We just allow creating new agents based on customized instances. And in the agent, what we need to do is to define the actions, action selectors, and verifiers. And because all the agents will follow more or less the same actions execution flow, then we just need to define different components on how they use it. Right, and we want to provide some default actions as default agents as well. For example, queue agent, NLP agent. But those things doesn't need to be a class anymore. We just need to provide them as some configuration file. I will show you later on. Yeah, then if some user can add new agents for different use cases, for example, they can just create it with by just writing configuration files, for example. The good thing about it is that basically the before what we do is like the agent and the agent action loop. So how the agent execute with it kind of mixed with the particular code for the use case. For example, if I have a programmer, then basically I need to write some code in order for the programmer to write code or verify that the code compiles. So that's some domain-specific logic that I have to write. Previously, if I create new classes and so on, this domain-specific logic will kind of get mixed with the agent logic of how the agent executes again. So with this strategy, what we actually achieved is that we completely separated the LLM logic, so how the agent executes, and what are the specific use case, the code you want to write on the specific use case. So of course, we also have the extendability if you want to write your own execution flow, but if you don't write, if you just use default reactor loop, then basically what you need to do is just declaratively say what actions you want to use, or define your own actions, and what action selectors and verifiers you want to use, for example. So this is the revised flow. So basically, instead of just defining agents with classes, we only define agents. Now we add configurations by providing what are prompts, what are actions, and verifiers, and so on. So this definition will be used to define an agent. So here we can also unify. So we have different ways of verification. If the verification fails for a number of times, then we try to ask help for others. And we also have, we can also select actions and action execution. So basically, now each agent would be defined by a configuration instead of writing new classes in Java, so in Python. All right, so now comes the tricky part. So I will provide some live demo for two different use cases that I think is interesting, and they are quite different. So basically, the first one, I'm not sure how many of you have already tried Sherpa on Slack. So the first one is actually I'll create a simple Sherpa kind of like question answering, like just like the one you can use on Slack within terminal by, I mean, maybe less than 10 lines of code, for example. So on the left, that's basically a very traditional use case that we have just for question answering. It can access Google search and it can also validate the citation, so it makes sure that the citation, whatever link the large model gathers, is valid. So that's one use case. The other use case is very different. So what I want to do is, I have in software engineering, we also have always have the problem that we have a domain description, and we want to generate, we want to write code for that domain description. For example, I have a bus transportation system, and want to write a system to management those buses. So in order to write those buses, normally in software engineering, what we do is that we need to write some diagrams, for example, the relationships between classes like buses, schedules, drivers, and so on. And there are some industrial strategy for us to generate code from those diagrams. So basically, the next what I will challenge is this software modeler. As you can see here, I need to include some domain-specific logic. For example, I need to integrate with other tools, which is not by default included into Sherpa, like this Ample tool or this diagram generation. This is GraphWiz tool. Okay, so without further ado, let me switch to the presentation. or switch to the VS Code. So this is a live presentation. If anything went bad, just assuming it goes well, thank you. But hopefully this will not be the case. Okay. Can you see my screen? Yes. So maybe I can make this a bit larger. So basically what I get here is that I have a little demo project that's basically created for the demo. So first I will try is this QA agent. So now you can see that each agent, instead of just creating like agents and configure its actions, it becomes basically configuration files like this, and it follows a particular template. And you can basically use this template to add new, basically define which actions and validations you want to use and configure each of them. So for example, here what I say is that because in Sherpa already provided Google search and the citation validation verification strategy, so I can just say I want to use them and provide the basically attributes of them, and also define the large model I want to use, and so on and so on. So here I define two agents. Just for simplicity, I just give one action you can use just to do some Google search, and at the end I want to validate the citation to make sure the citation works. Right. So for this, I don't need to have any external or extra code to be written. I just need this, and I have one small demo Python just to run the terminal, and so that I can input a question to it. All right. So basically, so let me try to run it. Right. Then basically I just give this configuration file to it. Right. So it starts to. This is a bit. Let me see if I can make this. Okay, so now it's maybe hopefully it's a bit clear. So yeah, so now it's raised, and I can ask a question for it. For example, I want to ask what are the popular LLMs now, right? So because I configured the environment to show all the logs, so you can also say all the execution logic. For example, it executes Google search. Those parameters, and it gives you those results as the search result. At the end, it tells you basically generates the results based on whatever the search result finds. It also includes the links, and because I enabled link verification, so those links would also work. For example, those are the links that basically referred by this results. And this is something that you can already try on Slack. It basically contains almost the same functionality, except on Slack, I think we have some more other extra actions that the agent can do. In this case, we only have Google search. So this is a simple use case. So the next use case is this modeler use case. So in modeler, I basically have a very similar configuration as, a very similar configuration as what I had before, like for example, logic model, shared memory, agent configuration, and so on. And I have one action just called deliberation, but really just call large language model to try to generate the software model that I want to generate. What's different now is I have a few other actions or verifications. So basically, because now I have to interact with other tools, I have to write some of the code. So here I just write code. The good thing here is that in this code, I don't need to worry anything about the larger model or anything like that. I just focus on, for example, calling the tool and generate the thing that I want. Like for example, here I just use Ample and try to generate some code from it. All right, so in order to just switch from this QA agent to the modeler, I just need to provide this modeler configuration to it. Because it's a simple thing, I don't use anything else. It just still say ask me a question, but really what I can do, for example, is I can give a domain description or say a requirement like this. For example, this is a bus transportation system. It says like the keeps driver's name and so on and so on. So those things. So let me copy this and give this to the modeler that I just created. Just bear in mind that there is a chance a large model may not be able to generate the thing that we want. But if that happens, we'll say what happens with it. Okay, so now what it says, okay, is that it starts to generating and seems that it has some problem with generation. For example, it will say, because it's called the tool, it say, okay, the model is not invalid because there are some problems with it. So it will basically, because this is a verification process, it will try several times. And can say like this doesn't really work out at this point. But what happens is that since, remember, we have a human in the loop concept. So basically what happens is now you tried 2-3 times of generation and find, okay, okay, I can't really figure this out. There is a problem, for example, there are multiple associations between classes. I will not go into details of the concept. So basically it says that the model it's generated is a bit problematic. But the thing is that the agent will generate an intermediate representation for you. And this is intermediate representation. And basically what you can say is you can help it to fix this problem by just looking at what's going on. For example, here it says that there's an error at 19, at line 14. Okay, I find, okay, there's bus assignment and there's bus, but different, so there are already a relationship between this assignment and bus. So we just remove one of them. And maybe I just want to check if the other things, and so on and so on. For example, in this case, check, right? So, so I can basically remove this, and I can press continue to just enter, and they will say, okay, maybe there are some more problems, and they will try to basically, you can interact with the agent to fix the problem with it. So just for the demoing purposes, I will just copy a correct one to here in the intermediate representation. Okay, and then if I try to fix it, and then I go it just to for the execution, so agent will try to interact with other tool and then generate things. So basically what it has at the end is that it generates a nice diagram for the domain. For example, here we have driver assignment, driver bus assignment, and so on. And also generates some code, but those codes are generated with the tool that we interact. So basically, it supports generating of intermediate representation like this one, and you can try to fix with it. And in this intermediate representation can be used with by the agent for calling subsequent tools to basically generate other things, for example, the Java code as well as a diagram like this. All right, so basically that's the demo I have. Let me switch back to the presentation. Okay, so okay, yeah. So just to recap, so the Sherpa is the expert or human in the loop execution. So basically, we have some agents, and we try to let the agent to interact with human to complete some tasks. So previously, the problem with this thing is that we have a lot of different agents, and we also want to support user to add agents. And previously, we basically used this based on the instantiation of new classes. But currently, what we come up with is that we can actually configure agents purely by just some configuration files. We can provide templates as default agents. So at the end, we use Hydra as the configuration file, and also use basically the support. It also supports you to create customized, for example, actions as well as verification strategies, and you can only focus on the particular domain that you are interested in. Okay, so I think last part I'll hand it back to Amir to conclude my presentation.
Okay, thank you so much, Percy. Yeah, I mean, I don't want to repeat some of the things that Percy said, but obviously this is an open source project. We're always looking for contributors. So if you're interested in this kind of topic, we're always looking for ways this can be improved and adapted for some use cases you have in mind. So feel free to check out. I put the GitHub link in the chat, so definitely take a look at that. We are also in the process of using Sherpa in some commercial projects. So we are essentially extending and customizing Sherpa for some commercial clients we're working with. So if you are involved in any projects that could use something like this, feel free to reach out to me through that link. It is also in the chat. I will copy it again. So yeah, feel free to reach out and talk to us, even if it is not exactly related to what you saw and you still want to chat, ping me up, hit me up, and we'll discuss your project and how we can help and how we can tap into our community and all of those good things.